Hi guys, Assalamualaikum warahmatullahi wabarakatuh. Welcome back with me. Before we get into the materials, let me introduce myself. My name is Hamza and I'm from Pattimura University, study program of civil engineering. This is my first video, and this video is one of the assignments given by the lecturers to us, and I will here to explain about soil mechanics, especially about subgrade lift. Before we go into the deep of materials, we must know what is subgrade. Subgrade in transport engineering, subgrade is the native material underneath a constructed road, pavement or railway track. It is also called formation level. The term can also refer to import material through has been used to build an embankment. In construction, subgrades are commonly compact before the construction of a road, pavement or railway track, and are sometimes stabilized by the addition of asphalt, lime, Portland cement, or other modifiers. The load-bearing strength of subgrade is measured by California Bearing Ratio or CBR test, falling weight deflectometer back calculation, and other methods. The subgrade is the foundation of the pavement structure on which the subbase is laid down. How is subgrade defined? A subgrade is made up of native soil that has been compacted to withstand the loads above it. It is a layer required in many structures such as pavement and slabs, although it needs to have certain characteristics. A subgrade might need special drainage structures to let water if it is composed of impermeable soil, and it should be grade to within plus or minus 1.5 inches of the specific elevations. There are no consistency in regards to the terms of subbase and subgrades, but normally the subgrade is the native soil while the subbase is the layer of soil or aggregate on top the subgrade. Subgrade performance. A subgrade's performance generally on two interrelated characteristics. 1. Load-bearing capacity. The subgrade must be able to support load transmit from the pavement structures. This load-bearing capacity is often affected by degree of compaction, moisture content, and soil type. A subgrade that can support a high amount of loading without excessive deformation is considered good. 2. Volume change. Most soils undergo some amount of volume change when exposed to excessive moisture or freezing conditions. Some clay soil shrinks and swell depending upon their moisture content, while soils with excessive fines may be susceptible to frost heave in freezing areas, as especially the Big Island can present volume change problems. Subgrade preparation is similar between all kinds of pavements such as surveying, excavations, testing, embankment construction procedure. Before placing the embankment on subgrade soil or placing subbase layer, subgrade materials should be tested to ensure that the materials meet the standard requirements. Some series of testing requirements as follows. 1. Particle size distribution. 2. Plasticity tests such as or Ethelberg limit by Cassegrande or Falcon test. 3. CBR, and 4. Organic material determination. One of the most essential tests, which is exceedingly mandatory in all cases, is particle size analysis test, used to determine the actual graduation of subgrade soil. The graduation should be uniform, and the amount of fine soil, such as clay and silt, should not more than the range of standard. If amount of clay present in the soil, plasticity tests should be carried out to check the plasticity behavior of soil because the plasticity directly relates to expansive or swelling ratio of soil. The high plasticity soil indicate higher possibility of expansive soil. CBR in most cases of the highway is required to determine the CBR value. CBR value in some cases is used for designing the pavement layer. According to the standard, which is used for the project, the soil should be tested in order to determine the percentage of organic material if it presents in some sections alongside the alignment. The organic content soil should be removed entirely and replaced by other type of soil. So that is enough for my presentations. Thanks a lot for my lecturer, Mr. Ronald Ayar, and friends, and thanks for watching.